Hello class, in this video I am going to go through your review assignment, okay? So you can see I have a blank review assignment right here and I'm going to walk through each of the problems and I am just realizing it says we start at problem 3. I'm sorry about that, that should say number 1. But anyways, moving on. Lesson 8.1, I can determine whether a relation is a function and write a function using function notation. So here we have directions. If f of x equals negative 3x plus 9, g of x equals 9x minus 23, and h of x equals 13x minus 17, find the function values. So then right here, the very first problem that we're looking at, number 3, is f of 3. So first, let's rewrite what f of x is. F of x equals negative 3x plus 9. Then I want to know what f of 3 is. So since I replaced x with 3, I need to replace x with 3. And then it's just order of operations. I have multiplication right here, so negative 3 times negative 3 is negative 9. And then I have negative 9 plus 9, which is 0. So f of 3 equals 0. And that is my final answer. If you just wrote 0, I'm okay with that as well, okay? Then let's look at g of negative 7. So I look up here and I say, what is g? What is the function g? And I'm just going to grab another pen quick. So g of x is 9x minus 23. So then I got that from up here in the directions. I looked for the function g. Now I'm looking for g of negative 7. So again, I replace x with negative 7. So then I have 9 times negative 7, which is negative 63. Make sure you use a calculator so that way you don't have to worry about accidentally multiplying wrong or subtracting incorrectly, okay? So 9 times negative 7 is negative 63. Negative 63 minus 23 more is negative 86. So you can either box it like that, or you can say g of negative 7 equals negative 86. Both answers are correct. Then, for h of 0, I need to look at what is my h function. So I go back up to my directions and I see h of x is 13x minus 17. So h of 0, I replace that x with a 0. And then 13 times 0 is 0. 0 minus 17 is negative 17. Be careful at the end there. A lot of you are going to see that 0 and then see the number 17 and just write that down and forget that you're actually subtracting 17. So you need to make sure you put that negative down in front of that 17. Okay, and that is how you do lesson 8.1. Okay. Then let's look at lesson 8.2. So lesson 8.2, I can describe sequences using words and symbols and find terms of arithmetic sequences. If I want to find the 12th term, let's say I start with negative 3, 4, 11, 18. Okay, so this is my first term, second term, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, and 12th. And now I just have to figure out what those numbers are. So to go from negative 3 to 4, I have to add 7. To go from 4 to 11, I'm adding 7. From 11 to 18, I am adding 7. So that means I have to add 7 every time. So 18 plus 7 is 25. 25 plus 7 is 32. 32 plus 7 is 39. 39 plus 7 is 46. 46 plus 7 is 53. 53 plus 7 is 60. 60 plus 7 is 67. And 67 plus 7 is 74. So my answer is 74. Okay? Hopefully that's not too bad. Then down here, this is a problem that's going to look a little different than what you guys did on your homework, but I'm going to explain it, okay? So, does the following equation describe the sequence? And then explain. So the equation we're given is a of n equals 2x minus 8. And we want to know, does this sequence match that equation? So let's figure out. Let's find my first, second, third, fourth, and fifth term. Oh, I'm going to move that one over a little bit. And fifth term for that equation. So if I plug in 2, and then I plug in 1 to find my first term, 2 times 1 is 2. 2 minus 8 is negative 6. If I plug in my second term, 2 times 2 is 4. 4 minus 8 is negative 4. And if I look, I haven't even found the first 5 terms, but if I look, my first term here does not match the first term there. So my answer would be no, the equation does not describe the sequence because the first term should be negative 6. And you can stop there. You don't have to find the rest of the terms. Okay? If you were doing this problem, and let's say these numbers matched, you'd have to keep going to see if they all matched. If they all match, then yes, the equation describes the sequence. If they don't match, then you do what we just did. Okay? So that is 8-2. This is what your 8-2 section of the test will look like with different numbers. Now let's look at 8-3. So 8-3, I can solve linear equations with 2 variables and graph linear equations using ordered pairs. So the first step, complete the table. Use the results to write 4 ordered pair solutions. So you have the table, you have the numbers already that you're going to plug in. So I'm going to say y equals negative 15 times negative 1 plus 12. And I can just go through and rewrite all of these so that way it is all set up to solve. And I'm just plugging in those numbers that I have for x over on the left. Okay. Now, negative 15 times negative 1 is a positive 15. Positive 15 plus 12 is 27. So that means my first ordered pair, when I plugged in the negative 1 for x, I got 27 for y. Now let's look at the next one. Negative 15 times 0 is 0. 0 plus 12 is 12. So my second ordered pair is 0, 12. Multiply by 2. Negative 15 times 2 is negative 30. Negative 30 plus 12 is negative 18. So then I write 2, negative 18. Then negative 15 times 4 plus 12 is negative 48. So then my last ordered pair is 4, negative 48. And that's all you have to do for that problem, okay? Now graphing is where we tend to get a little confused. So let's look at this equation. We have 4x plus 5y equals 20. This is where we're looking for our x-intercepts and our y-intercept. When you are looking for your x-intercept, you keep x. When you're looking for your y-intercept, you keep y. So what I'm going to do is I have 4x plus 5y equals 20. But since I'm solving for my x-intercept, what I can do is I can get rid of the y term. So I'm actually just going to scribble that out. So then I'm left with 4x equals 20. Now I solve for x. I have 4x. That's the same as saying 4 times x because there is no addition between them, subtraction, or division, which means it has to be multiplication. So how do I undo that multiplication? I am going to divide both sides by 4. So that way the x can be by itself. So 20 divided by 4 is 5. That means my x-intercept, I'm going to go over here. I'm going to find x equals 5. Since it's a positive 5, that means I'm going to count 1, 2, 3, 4, 5, and put a point right there. Try to choose a brighter color so it'd be easier to see. Now for the y-intercept, you are going to keep the y. So 4x plus 5y equals 20. This time we cross out the 4x, so I can scribble that out. I'm left with 5y equals 20. So then to get y by itself, I have to move that 5, and again, it's being multiplied, so I can divide both sides by 5. I'm left with y equals 20 divided by 5 is 4. Since that's positive, that means I go up 1, 2, 3, 4. And then I'm just going to connect my dots, and that is my answer. Okay? So that is how you will graph on your test. For your test, if you print it out, you'll automatically have a graph. If you do not have a way to print out your test on Monday, what you can do is draw your own graph. And I'm not super concerned about your line being perfectly straight. What I am going to be picky about is making sure that your points are in the right spot. So if you're worried about me not knowing where exactly your points are, you can label them. So you can say that this is at 0, 4, and this is at 5, 0. Okay? That is one option to make sure I don't question where your points are. All right? If you have questions on that, let me know. And let's move on to the last section of the unit, or of the first half of chapter 8 at least. Okay. 8.4, I can find rates of change and solve problems involving rates of change. So find the rate of change for the linear function below. Remember, this is where we talked about you take your y value, and that's going to go on top. So in this case, I'm going to choose to use these 4 points, or these 4 numbers. So I'm going to take my y, and I'm going to subtract the number that came before it. So 0 came before 3750, so I'm going to subtract 0. Then, since I started with 3750, that means I have to start with 3 on the bottom. So I'm going to say 3 minus 0, since 0 came before 3 on the table. Now, 3750 minus 0 is just 3750. 3 minus 0 is just 3. So then I'm going to divide 37.5 divided by 3, and I find out that the answer is 12.50. And I'm going to label it because the table tells me that y represents the money earned, and X represents the hours, okay? So $12.50 per hour would kind of be your answer. If you just write $12.50, I'm okay with that. I'm not going to be picky. However, I will not accept this as a complete answer. You need to make sure you simplify, okay? Now let's look at the bottom. This is that table that looks a little more complicated, but it's the same idea as what we just did. So I'm going to start with, we have the table shows the total cost of tickets. Compare the rates of change. So we want to compare adults and children with each other. So I'm going to start with the adults, okay? And I'm going to use just my first numbers, okay? So again, we start with our y value. So I have 200, and I'm going to subtract the number that came before it. So 200 minus 100 over 4 minus 2. Because then you go to your x, you say what number lines up with the 200? That would be 4. And then 2 comes before 4. 200 minus 100 is 100. 4 minus 2 is 2. 100 divided by 2 is 50. So adult tickets are $50 each. Now, let's look at children. So I'm going to use just the top two numbers again. If you wanted to use the top and bottom numbers, that's okay. If you wanted to use the bottom two numbers, that's okay. I just like to work with the first numbers I'm given. That's all. So then I have children, and my first y value that I'm going to work with, I ended at 120 minus 60 is the number that came before it, over, I ended at 4, and the number that came before it was 2. So 120 minus 60 is 60. 4 minus 2 is 2. 60 divided by 2 is 30. That means adult or children tickets are $30 a piece. So then the last step comes, compare the rates of change. So you could say something like adults are $20 more per ticket. You could say something like that. That isn't the only answer. You could say children are $20 cheaper than adults. There are lots of different correct answers, but you need to do something where you compare these two numbers that you got together, okay? So that's the last step for that problem. If you have questions on any of these, be sure to reach out for some help. Remember, there's help offered in the afternoon, so make sure you utilize that. Have a fantastic day.